Hello everyone, the Teen Engineer here, and let's try to solve this linear momentum problem that we have on the board. So let's read it. A 17 kilogram object with a velocity 6.5 I meters per second explodes into two equal fragments. One flies off with a velocity 3I minus 2J meters per second. What is the velocity of the other fragment? So let's draw this. Initially, we have the 17 kilogram. And it is going at 6.5 I meters per second. Now, the 6.5 I means that there's only an x velocity at the beginning. Now, there is one that flies off. Into two equal fragments, they have to be 8.5 kilograms each to make up 17. So you just divide 17 by 2 because they're both equal fragments. So one flies off with a velocity 3I minus 2J. So let's draw that. So 3I, let's say, and then that would be like 2J, something like this. Okay, so that will be 3I, and that will be 2J. And then the velocity of the other fragment. So we'll have another fragment here, 8.5 kilos. And we want to know its velocity. So let's start off with the conservation of linear momentum formula. You're pretty much always going to use this. I is equal to PF. And so initial momentum. Now I'm going to use unit vectors as it's going to make things way easier. So 17 kilos times 6.5 I meters per second. It's going to be equal to 8.5 kilograms, and then we're going to keep that there. So what? Minus 2J, 3I minus 2J. That's the velocity of this one here, and this one here. And now this one, we're just going to keep it like that, times VF, which we're going to find because this is what we're trying to find. So let's simplify everything. 17 times 6.5, 110.5 kilogram meters per second, and I should have put the I before the units. Just delete that. I kilogram meters per second. Now let's distribute that. The I's and the J can never add or subtract. So 25.5 I kilogram minus 17 J kilogram plus 8.5 VF. All right. So now let's bring all of those to the other side. So the I's, we can add and subtract with the I's. So this one is an I, this one has an I. So that would be 110.5 minus 25.5. That would be 85 I. And that should be meters per second on those because those are speeds. So that should be meters per second, kilogram meters per second. And then we're also going to take the J to the other side, but we cannot add it to the I. So it will be plus 17 J kilogram meters per second. It's going to be equal to 8.5 VF. And now we can divide everything by 8.5. So 85 divided by 8.5, that would be 10. Meters per second plus 2 meters per second. It's equal to VF. And that's the final answer in unit vector. You can put it into any other form that you like. And that's pretty much it for this problem. And yeah.